just to remind you, this is a situation where we have the product of two functions of x, and we want their derivative. What you don't do this. The derivative of the product is not the product of derivatives. It's this staggered product or mixed product where you do the derivative of one factor at a time and then add them up. That's the so-called mixed product, which is a very common pattern in math, in statistics. You know, what's important is for you to be able to use it. So let me do some examples. How about number 3? Here we're given the square root of x times the log of x. So p is root x, q is log x. And maybe just to refresh your memory, allow me to rewrite root as power 1/2, because now I can use our power rule. So what we want to do is we want to take the derivative of this product. And so what our rule says is take the derivative of the first factor times the second factor untouched as is, then add to it the reverse. The first factor untouched times the derivative of the second factor. Now, when you're doing the problem, you wouldn't write that out, you would simply just do it. So according to the power rule, that derivative is 1/2 x to the negative 1/2 log x plus x to the 1/2. The derivative of log x, remember, is 1 over x. And let me refresh your memory on this step. Remember that if you want the derivative of x to the n, the old power is a new coefficient, the new power is 1 less. And that's the rule we're using here. N is 1/2, comes down in front, new power is 1 less. 1/2 subtract 1 is negative 1/2. And then here, this was simply just given to you, the derivative of the log is 1 over. So if this were a problem and you left it like that, I'm perfectly happy. But I just want to remind you. So what does negative 1/2 mean? It means the negative is reciprocal, the 1/2 is a root. So is it okay? What negative 1/2 means is reciprocal and root. You have root x in the denominator. And 1/2 means you have a 2 in the denominator. And here, can't I simplify a little bit? Because x means x to the first. And so how would you, I'm just reminding you of the rules, a to the b over a to the c, that's 1 over a to the c minus b. If you bring this down, you subtract it. So this is equal to 1 over x to the 1 subtract 1/2 is negative 1/2. Or, recopy, negative means reciprocal. It's all root x. So you could leave your answer like that on the first midterm. On the first midterm, you don't have to simplify. On the second midterm, you're starting to work with these things, you're starting to use them, And so working with the derivative, using the derivative, you might have to simplify it in order to work with it, which is why I'm trying to remind you of the rules as we go along. But for the first midterm, if you leave it like that, it's perfectly fine. How about number 5? So here we have e to the x times x squared minus 3. So e to the x is your p, and x squared minus 3 is your q, and we want the derivative of it. So you would not write the following. Just let me do it slowly. The product rule says you first take the derivative of the first factor times the second factor untouched, plus now the reverse. The first factor untouched times the derivative of the second. So you would not write that. I'm just trying to write the instructions. Remember, e to the x is its own derivative. That's the nice, weird property of e. Plus e to the x. And now, x squared, the derivative is 2x. Minus 3, though, is a constant. So its derivative is 0. You wouldn't write 0 there, you just leave it 0. It's not wrong if you do. So this e to the x, x squared minus 3 plus e to the x times 2x. That's fine. And only because you're going to be working with it, you could simplify this as e to the x, x squared minus 3 e to the x plus 2x e to the x, if you will. Or you could come midterm 2, where we're having to work with these things. You might have to do some of these manipulations. But, that's fine. Leave it there. That's good. Let's do number 9. So here, we're given a function f of x as e to the x plus 1 times root x plus 1. And I'm just reminding you that root x means x to the 1/2 power. Fractional powers and roots. And so now, f prime the derivative. I had been using the d notation. Remember, they're totally interchangeable. They mean exactly the same thing. Take the derivative. And so, what does your rule say? We're going to take the derivative of the first term times the second term untouched, plus now the reverse. The first term untouched times the derivative of the second term. And so here in problem 9, I'm using the prime mark for derivative instead of the d. Never mind. Total interchange. So the derivative of e to the x plus 1 is just e to the x, because 1 is a constant's derivative is 0, times the second term untouched plus now the reverse. Keep the first term untouched, and I want the derivative of x 1/2. 1/2 comes down in front. The new power is 1 less, a half, subtract 1, and the derivative of 1 is 0. And leave it that way. I'm only reminding you what the notation means. This is root x plus 1. And this puts a root in the denominator, right? Negative 1/2, root in the denominator. So this is e to the x plus 1 over 2 root x. So you can leave it that way, but do you understand the rules? You know, as I say, it's sort of not your fault because of that COVID hiatus. But I've come up with some, if you've got 1/2 times something, if you want, you could write that as 2 in the denominator. I've had people stumble with this kind of stuff. So if there's some bit of algebra I'm doing that you don't understand, please ask. And now number 11. So f of x is equal to 2x minus 3. Oops, I left off log x, sorry. F of x is 2x minus 3 log x times x plus 1 over x. And I'm just reminding you recopy. Here I just want to remind you that 1 over x means x to the 1/2, because now we're going to do the power rule of that. So f prime, take the derivative of the first factor. The derivative of 2x is 2. 3 is a coefficient, it stays. The derivative of log x is 1 over x, times the second factor untouched, plus now the reverse. First factor untouched, times the derivative of the second factor. Well, the derivative of x is just 1. And now here's a power rule. The negative comes down in front, and you have x. The new power is 1 less. Negative 1 subtract 1 is negative 2. And feel free to leave your answer that way. But of course I could write 3 over x, okay? 3 times 1 over x. And here's x plus 1 over x. Recopy. You notice when I wrote log, I forgot to put the x. I don't know if you noticed, I snuck it in there. You really should put the x there. Don't just write ln. You should write ln x. and x to the negative 2 is 1 over x squared. Are we okay? Now, what you have to be able to do on an exam is just this. Use the product rule. You don't have to spit back the proof of the product rule, but you don't have to spit this back. Let me show it to you. Let me show you the proof of the product rule, simply because everything flows from the definition. Why did we spend 2 weeks on this basic definition of the derivative? So you don't have to remember this proof. And we're about to learn the quotient rule. How do you take the derivative of a quotient? You don't have to spit back that proof. But let me just show you to try and say why this was so important. Our product rule follows from this. Let me just show you. So what I want to do, I want to prove that the derivative of the product is the mixed product. So that's what I said you do. You got a product, and you got 2 factors. You take the derivative of one factor at a time and then add them up. That's your product. And so here's the proof. All I've got to work with is this definition. So the derivative of p of x, q of x, here's the definition. It's the limit as h goes to 0 of. Put in x plus h. Subtract x all over h. That's the basic definition that we have to work with. Well, what am I going to do? Yeah, this is sort of a trick. Yeah, it's sort of a trick. But it's a trick that often works. What I'm going to do is I'm going to come up with something magic. I'm going to subtract it away there, and I'm going to add it there. Now you know, every step in math, whether you're talking about basic arithmetic or advanced calculus, every step in math has to be simultaneously 2 things. It has to be true, and it has to be useful. Which is what makes math so hard. You have to continually double think. It's got to be true, and it's got to be useful. So this is true. I can subtract something as long as I add it back in. That's true, for whatever I put in blue. Now, what's going to be useful? What's going to be useful is take one of these factors and one of those factors. So let's take p of x and q of x plus h. So take one factor from each. P of x times Q of x plus h. So it is legal. I add and subtract the same thing. Now what I'm going to do is I'm going to break this into two fractions. I want to look first at this group, and then I want to look at that group. So let's look at the first group. That's going to be P of x plus h, Q of x plus h, minus P of x, Q of x plus h. Now I want to look at the second group. Now this is the negative one. Let me write it here. Negative P of x, Q of x. So I'm writing that negative over here, and this here blue is the positive. Okay, I'm almost there. Now on this one, the numerator has two terms, and the two terms have a common factor, Q of x plus h. Factor that out in front. Q of x plus h. Which leaves me with what? P of x plus h minus P of x all over h. And here, same jazz. The two terms of the numerator share a common factor, P of x. Factor that out in front. But now looky. The limit as h goes to 0 of that, that's the definition of the derivative. The limit as h goes to 0 of that is the derivative of p with respect to x. And here, as h goes to 0, I simply have q of x. Now over here, this, the limit of q x plus h minus q of x over h, all of that is simply the derivative of q times p of x. And behold, there's my chain rule. So you do not have to memorize that. I wouldn't ask you to spit that back on an exam. My purpose in showing it to you is that's why we spent so much time on this definition. The derivative of f with respect to x is the limit as h goes to 0 of f of x plus h minus f of x over h. And so when you come up with a new rule, that's the definition you got to go back to and work with it. So that's where the product rule comes from. It comes from this definition. Now, the quotient rule. I'm about to show you the quotient rule. And we could do a similar proof of the quotient rule. I won't. Because you don't have to spit it back. I just want to show you why that definition is so important. Everything flows out of that definition. I'm wanting to say things that you don't care about. Really, it took 25 centuries of thinking to come up with that definition. As I said, instantaneous speed. The question immediately involves division by 0. Speed is distance over time. But if you have an instant, how much time is an instant? 0. You're trying to divide by 0. But yet, people were thinking about instantaneous speed since the ancient Greeks. Maybe in philosophy class, you came up against some of Zeno's paradoxes. Zeno's paradoxes. Like the arrow in flight. Zeno proved arrows are impossible. Because if arrow is actually moving, then it's still at this instant. And how does it get to the next instant without dividing by zero? Another one, Achilles and the tortoise. Achilles and the tortoise are going to have a foot race. The tortoise is slow, Achilles is fast. So Achilles gives the tortoise 100 yards advance. And they start running. Well, before Achilles can overtake the tortoise, Achilles has to reach the 100-yard mark, by which time the tortoise has advanced. And so before Achilles can pass the tortoise, he has to reach position 2, by which time the tortoise has advanced to position 3. And Achilles has to reach position 3, by which time the tortoise has advanced to position 4. And you got an infinite sum. Therefore, Achilles can't overtake the tortoise. They sound silly, but they were right to the point of infinite series and division by zero. And it wasn't until Newton and Leibniz in the 17th century that they were able to come up with a way of defining instantaneous speed. But even then, Newton in England, Leibniz in Germany, they had something called, the only way they could do it is something called infinitesimals. And an infinitesimal, you know that one point has no length, and a line segment has an infinite number of points. So one point has no length, and there are an infinite number of points in a line segment. But an infinitesimal was some creature which alone had no length, but a finite number of them would make up a line segment. Huh? One alone had no length, but a finite number of them could add up to a line segment. So the infinitesimal somewhere lived between a point and a line segment. And it was a mythical creature. But that's the way they did calculus for 200 years and ended up with all kinds of paradoxes. And it wasn't until Weierstrass in the 19th century that used limit to put it on a firm foundation. So this is something that people have been working on for 25 centuries. I also teach a history of math course, and you do not care. Okay, never mind. Quotient. So this now is the new material. I could prove the quotient rule again from the limit definition, but I won't. So here's what the quotient rule says. You want the derivative now of a quotient, p divided by q. The biggest single mistake on the second midterm, half of you are going to do this. It ain't the derivative of the quotient. The quotient of a derivative is not the derivative of the quotients. And most of you will do the first midterm fine. But when we start doing applications on the second derivative, half of you are going to fall back into that. In spite of my protestations to the contrary. Here's what you do. And I grant you, it's a bit more complicated than the product rule. But you have to learn it because it's useful. Here's what the quotient rule says. Denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the old denominator but squared. So I realize that that's more complicated than the product rule. But in trying to learn it, look at the numerator. Notice it's sort of like that mixed product. You know, do it to one factor at a time, but they're subtracted. So it matters who comes first. Another big mistake. People get the numerator switched. They say, okay, numerator times the derivative of the denominator minus the denominator times the derivative of the numerator. Subtraction matters. It matters what comes first. And so this is a very common mistake. They switch the terms of the numerator. Now, if you do that, unlike this one, this mistake here, you're blown out of the water, nothing is true. Here, you're off by a negative, right? Because this mistake is the negative of that mistake. So it's wrong, but you're off by a sign. If that's all you do, I'll take off half a point because you made a sign mistake. But it's a half a point for every occurrence. And if you've got 3 or 4 of these, ouch, that's a lot of points. Okay? So be sure that you get it right. Denominator times derivative of numerator minus numerator times derivative of denominator over the denominator squared. Let me do some examples. How about if we do x squared plus x plus 1 over e to the x? Okay. Denominator times the derivative of the numerator. X squared goes to 2x, x goes to 1, plus 1 is a constant derivative is 0, minus numerator times the derivative of the denominator. Oh, e to the x is its own derivative, how nice, over the derivative squared. Now, on the first midterm, if you leave your answer like that, I'm perfectly happy. But on the second midterm, you start using these things. And so you need to simplify. Do you see how it simplifies? Do you see first here in the denominator? When you have the power of a power, do you remember what you do? When you got a power of a power, you multiply. And notice in this case, you've got 2 terms in the numerator. They share a common factor of e to the x. You could factor an e to the x out of the 2 terms of the numerator. Is that okay what I did? This is simplifying for the second midterm. I have these 2 terms. They both share a factor of e to the x. And now, do you see some simplification? Do you see some subtraction? You can cancel one of these x's with one of those, leaving you an e to the x in the denominator. Is that okay? E to the x over e to the 2x. When the bases are the same, you subtract the powers. So x from 2x is x. And here you're left in the numerator with 2x plus 1 minus x squared minus x minus 1. Is that okay? You're subtracting parentheses. Be sure to distribute the negative sign across parentheses. And so, more simplification. 1 subtract 1. And you're left with negative x squared. 2x subtract x is plus x. And so, as I say, for midterm 2, you're going to have to work with this, and isn't that a lot easier looking than that? So, you know, on the second midterm, you'd be simplifying and working with that. Let's do another example. I'm going to rig a problem. High school algebra. They should have shown you this, and I bet they didn't. If you've got, you know the difference, this you remember. You know, that's not showing up very well. I like to save blue for algebra view. Let's see. My bag of pens. I thought I've got dozens of pens down here. What was that one? Yay! No. Okay, I'll have to do it. So you remember that if you have a difference of squares, that you remember, or at least you should. But did they show you a difference of cubes? A cubed minus b cubed. They should have. That's a minus b times a squared plus ab plus b squared. So therefore, if you've got x cubed minus 1, it equals x minus 1 times x squared plus x plus 1. I'm trying to come up with a nice quotient rule. So therefore, let me divide that factor into the left. X cubed minus 1 over x minus 1 is equal to x squared plus x plus 1. So what I'm going to do, just to illustrate the quotient rule, I'm going to take the derivative of that quotient, and I better get the derivative of that. So let me recopy. We know that x cubed minus 1 over x minus 1 turns out to be x squared plus x plus 1. So, the derivative of the left should equal the derivative of the right. If two things are equal, their derivatives should be equal. But this one's here is easy. That's an easy polynomial. That's 2x plus 1. So let me do the quotient rule of that, and I better get 2x plus 1. So I want to illustrate the quotient rule. So I want the derivative of, so P is x cubed minus 1, Q is x minus 1. So if I write out my rule, P over Q, here's the rule. Denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. So let's do that. Here's Q and P prime. X cubed goes to 3x squared, and negative 1 is a constant, its derivative is 0, minus P, which is x cubed minus 1, times the derivative of Q, but the derivative of x is just 1, and the derivative of negative 1 is 0, over the denominator squared. So that's what my quotient rule gave me. And if this were a problem on the first midterm, leave it like that. But I just want to do algebra. I want to simplify to show it equals 2x plus 1. That's what it's supposed to equal. So let's do the algebra. All right. So let's let's expand the numerator. 3x cubed minus 3x squared. So distribute and subtract x cubed minus 1. And so 3x cubed minus x cubed is 2x cubed, minus 3x squared plus 1 over x minus 1 squared. Yeah, I was afraid that was going to happen. Because now to simplify that, do you remember? I don't assume you do. Do you remember polynomial long division? That's what I'd need to simplify that. So let me take a different path. Let me come here. I can do a different path. X cubed minus 1. Let's factor that. So that's x minus 1, 3x squared, and x cubed minus 1, that factors into x minus 1, x squared plus x plus 1, over x minus 1 squared. And you see now I can cancel? There's a term, there's a term. They share a common factor of x minus 1. So factor out the x minus 1, leaving me a 3x squared minus x squared plus x plus 1 over x minus 1 squared. And so you see I have a little cancellation here. One of those, one of those. And so that leaves me 3x squared minus x squared minus x minus 1 over x minus 1. 3x squared minus x squared is 2x squared minus x minus 1. over x minus 1. How are you with factoring trinomials? I hope, yeah, this is not a waste of time. I hope, you see these three terms in the numerator? That's called a trinomial, three terms. You can factor that into the product of two binomials. This step, there's a little bit of algebra here. That's going to be important in the second midterm. Can you factor that? The only way you can get a product of 2x squared is the 2x and x. And here, the only way you can get a 1 is the 1 times 1. And so you need negative x. So you need a minus there and a plus there. So I hope that this step here, I hope that's not weird to you, because come second midterm, we'll review it when we get there. But you're going to have to factor trinomials on the second midterm. And now you got x minus 1 as a common factor cancel, and you come up with 2x plus 1, which is what we said it should be. Okay? So with that, over the weekend, you can finish off 4.2, and come Monday we'll talk about Chamber. See you Monday.